Good morning, class. So you should, at this point, you should have already written down your I can statement and your name. So take a moment to do that if you have not done that already. That's over here, and then you should know your name to be able to do that, no problem. So today, what we're talking about is we're going over the few different ways that we've learned how to divide with fractions. You'll be practicing all three of those today. The first one is the one that we worked on yesterday. I think it's the more challenging one, so we're going to just work together. So while I'm writing, you're writing as well. And of course, since this is a video, I can't see how fast you're writing, so you need to just keep up with me. So here we have 3/4 divided by 2/5. This is the partitive interpretation. And so what that means is we're not going to take 3/4 and divide it into 2/5 sections. We're going to ask ourselves, 3/4 is 2/5 of what? So the first thing we need to draw, you can see actually is right here in the steps. It says shade 2 of the 5 sections. So first we're going to draw ourselves a model that is in fifths. When you're doing partitive, you always start with that second number. So let's make this into fifths. I'll put one more box there. And we need to shade 2/5 of this. And so now let's bring us back to our question. That 3/4 is 2/5 of what? So we know that 3/4 is the 2/5 part right here. It says label the part that is known. That's the 3/4. And now using this chart, we are able to figure out how much the total is. This is what we're seeking out. We are trying to figure out how much that is worth. So if we know that 3/4 makes up these two boxes, we've got to ask ourselves, well, how much is just one of those boxes? So if we take 3/4 divided by 2, what we're going to end up with is actually 3/8. So each one of these right here is 3/8. Add them up all together. You add up the 3, 3, 3, 3, 3, and you are left with a total of 15/8. Or if we write that in the other form of fraction, this would be 1 7/8. So that is one way for us to solve these problems. Take a moment, turn your page, and we'll get to work on the next way. We are on to the guided practice portion. Nice work with the last section. Now notice with this one, it says model the following using a measurement interpretation. With the last one, we were using the partitive one, but this is going to be different. Now one key that you must know for a measurement interpretation is that the denominators have to be equal. So this is a problem that's not set up in a way that we can divide this yet. We've got to get it set up so that they are equal. So we got to be asking ourselves, what is a number that we could get on bottom of both of these fractions? We're going to have to use multiplication to adjust these. So think for a moment. I'm going to give you a few seconds to see if you can adjust these fractions to get them to be the same denominator. And I'll just kind of wait here awkwardly while you think. Alright, so let me take you through this. So what I'm usually thinking is, if I don't know what is going to be a number that can be a denominator that's in common, I will multiply these two together, and that may work. So for example, if I multiply these two together, what we'll end up with is a denominator of 20. So if my denominator for the first number is 20, 5 was multiplied by 4 to get there. So we've got to do the same thing with the 3. So 3 times 5 is 15/20. And now we're going to divide this by, now this was multiplied by 5, so 4 times 5 is 20. And we got to do the same thing now with this one. We got to do 1 times 5. Oh, I apologize. This over here, guys, was 3 times 4. It's 5 times 4. And it's also 3 times 4. So now we have 12/20 divided by 5/20. And now this is something that we can set up with a tape diagram. So first now we want to represent this right here. We're going to represent 12/20 with a tape diagram. You're going to need lots of boxes for this one, because we need 20 of them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. All right, so we have our tape diagram set up with 20, but of course we have 12 over 20, so we need to shade 12 of these. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is 12 out of 20. Now we're asking ourselves, how many sets of 5 over 20 will fit into 12 over 20? So let's count it out. So we got to count out our 5. So this is 1, 2, 3, 4, 5. That's 1. Count another one. 1, 2, 3, 4, 5. That's another one. So far we have 2 5/20ths in 12 over 20. And we count 1, 2. Oh, we only have 2 fifths of another one. So we've got 2 and 2 fifths, and that is how many will fit into this. So our answer to this is 2 and 2 fifths. So if you are not convinced that this is right, feel free to try this with the other method that we'll be talking about. I know it's many of your favorite method, where we simply multiply by the reciprocal. But that's what we'll be moving on to in just a minute. Okay now, class, it's time for your group work. So get to work on this problem, and if you need help, you have to ask the real me. Bye. Scholars, you have a little bit of time to do some independent work. Now this is with your favorite method, so I think you guys will be able to fly through this. This is where we realize that dividing is the same exact thing as multiplying by the reciprocal. So when we have 2/3 divided by 1 over 4, we really know that that's the same exact thing as 2/3 times 4 over 1. Then of course we multiply across the top, across the bottom, and simplify if possible. Same thing over here. I just want to help you guys get started. So 2/3 divided by 4 is the same thing as 2/3 times 1 over 4. Remember, this is a fancy term called the reciprocal, but all it really is it means you take a fraction and you flip it. So go ahead, take a few minutes to do this independent practice. As soon as you're done with it, go ahead and get to work on your exit ticket. Move on to your exit ticket. Do your best on it. Remember that these are always graded. And for this one, number 1 says write the reciprocal of these numbers. You put it in the box. Scroll, please. For number 2, you're going to rewrite this division expression as a multiplication one. And then finally, for number 3, you will draw a model to solve problem 2. And that's it. Enjoy.